Through this kit's lessons, students by now have examined physical properties of matter and have experienced matter dissolving or vanishing in a solution, only to later discover it was still there the whole time. Lesson 2.9 will build on this understanding by exposing students to mixtures that produce some unexpected results. Even within mixtures where a new substance forms or properties change, the total amount of matter within a closed system remains constant. To bring more engagement to this lesson, we recommend you change the focus of the learning objective from a statement demonstrating the law and conservation of mass to an authentic question. When something vanishes, where does it go? Demonstrate this phenomenon to the class with an antacid tablet, test tube, and balloon. Go over the materials for this lesson, such as baking soda and vinegar, and ask students to consider why we might need to perform these experiments within closed systems. In the example of the test tube and the balloon, when we add the antacid, we should notice a reaction. Oh! And yet, within the balance beam, even as we see matter supposedly be produced from nothing, the balance should remain fairly constant. This result will also be replicated when we try this with the vinegar and the baking soda. To activate the baking soda and vinegar can be a little tricky within a closed sealed bag. And so you may want to model this process for students ahead of time or inform them to do so very, very carefully and make sure the bag is sealed to prevent spills or the gas from escaping. Also, you'll notice I'm wearing these fancy safety goggles. It should be required for students to wear goggles during this experiment because we're making closed systems and mixtures under pressure. So if we what I would recommend is carefully take the vinegar part, the bag is closed and sealed, and I'm just going to dump the vinegar into the baking soda, and then I shall try to leave it alone on the balance. And even as the bag inflates and the gas is produced, the balance should remain fairly constant again. The results of this is a step towards confirming that matter is conserved even when it appears to change form or be produced. Students should have evidence when they weigh the sealed bag that the total amount of matter remains constant. If the measurements don't match perfectly, as even in my example, use this as an opportunity to have students develop an argument for why they think the results may have been a little off. It is likely that some gas may have escaped through the imperfect seal of the bag.